Objective 3. Determine t-values. Recall that the notation z subscript alpha is used to represent the z-score whose area under the normal curve to the right of z subscript alpha is alpha. Similarly, we let t subscript alpha represent the t-value whose area under the t-distribution to the right of t subscript alpha is alpha. See the figure below. This represents the area to the right. Now, the shape of the t-distribution depends on the sample size n. Therefore, the value of t subscript alpha depends not only on alpha, but also on the degrees of freedom. We take the sample size of n and subtract 1. In Table 7, you will see that the far left column over here on the left-hand side gives the degrees of freedom. The top row represents the area under the t-distribution to the right of some value. So, what we want to do now is we want to be able to find t-values. So for this example, we want to find the t-value such that the area under the t-distribution to the right of the t-value is 0.10. Assuming 15 degrees of freedom, that is, we want to find t with an area subscript to the right of 0.10 with 15 degrees of freedom. So for step 1, we're going to draw the t-distribution with the unknown t-value labeled. So therefore, there is the t-value. We're going to shade the area under the curve to the right of that t-value. The graph of the t-distribution with 15 degrees of freedom. Now the unknown value of t is labeled and the area under the curve to the right of t is shaded. Now in order to find the value, if you take a look down here, it says find the row here in the table 7 corresponding to 15 degrees of freedom. So if we take a look at that, there is the row that represents 15 degrees of freedom. Okay, so that is the first thing that we do. Okay, and then we need to find the column that is corresponding to the area in the right tail of 0.10, which is this column here. And so we're going to identify where the row and the column intersect. So if you notice, they intersect at the value of 1.341. This is the unknown t-value. So a portion of Table 7 is shown here in this figure. We have enclosed the row that represents 15 degrees of freedom and the column that represents the area of 0.10 in the right tail. Again, the value where the row and the column intersect is the t-value we are seeking. The value of t subscript 0.10 with 15 degrees of freedom is 1.341. And that is the area under the t-distribution to the right of t equals 1.341 with 15 degrees of freedom is 0.10. The critical value of z with an area of 0.10 to the right is smaller, which is approximately 1.28 if we find that in Table 5. This is because the t-distribution has more spread or more area in the tails than the z distribution. Now, when you're using Table 7, when the degrees of freedom are not listed, if we go back up here, we can see that we have everything listed all the way up until we get to 40. And then it goes from 40 to 50, 60, 70, and so on. So, if the degrees of freedom we desire are not listed in the table, or Table 7, choose the closest number in the degrees of freedom column. So, for example, if we have 43 degrees of freedom, we use 40 degrees of freedom from Table 7. In addition, the last row of Table 7 lists the z values from the standard normal distribution. You use these values when the degrees of freedom are more than 1,000 because the t-distribution starts to behave like the standard normal distribution as n increases. And if you look at the bottom here, you can see where it's listed as z.